Let's let f of x be given by this model here. Let's put a point there, there, and also here. Okay, so what if we go like, let's go like that, let's go like this, let's go like that. And let's say this is x equals -4, -2, let's go with 1, 5, and let's say 13. And what kind of questions are they likely to ask us? Something like part A, when is f increasing? How about part B? When is f decreasing? And maybe part C, when is, let's say, f prime positive? And in part D, when is f prime negative? So let's say that you have all these questions here, parts A through D. Why don't you pause the video and try to answer these questions? Because I'll go through the solutions in 3 seconds. 3, 2, 1. Here we go. Part A. So when is f increasing? Well, the good thing here is that the picture that you're looking at, all of this picture belongs to f itself. The actual picture is what you see, the actual graph of f. So when exactly is f increasing? Well, look, if I go from left to right, if I trace it, look, the pen is going up. The marker is going up. And then here it's going down, so that's no good. But then look, it goes back up. So I would say that all of the red is when the original picture is increasing. So that would be like for part A, the answer would be like -infinity to -2, and then union from 5 to infinity. Right? These are the x values during which the picture is going up. Let's go ahead and put some arrows there and there. Part B, when is the picture decreasing? So we said that it's going down during this portion there, during that part of the ride, which would be from -2 to 5. Done, done, done. Now, what about for part C? So it wants to know when the derivative is positive. So let me switch colors here. Let's go with purple. And I want to remind you of something. Remember that we said in class that f is increasing. That goes hand in hand with f prime being positive, right? So a function is increasing and its derivative being positive. They mean the same thing. So part C, when is f prime positive? Well, f prime is positive when f is increasing. But dude, that's exactly what part A was talking about. So what I want you to see is that really part A and part C, they describe the same thing. And so the answer to part C would be the same as the answer to part A. So really, I'm just going to call that like A and C. And it's the same thing for part B and D. A function f is decreasing when its derivative is negative. So really the answer to part B would also be the answer to part D. Yes, yes, yes. So maybe you already knew this example, but now why don't I do this? Let me switch some of these things. I want to keep the same picture, but here the directions are different. Let me scratch that off. Now, let's pretend that the graph that you're looking at, instead of it being the graph of f, no, no, no. Now it's going to be the graph of f prime. Okay? So now you're looking at the picture of the derivative. And for part A, here's what it's asking. When is f increasing? part B, when is f decreasing? And then check this out for part C. When is f double prime positive? How about these three questions here? All right, let's grab this and leave this there. All right, so let's reset our minds here. Now let's pretend that the picture that we're looking at is the picture for f prime, the derivative. Part A is asking about f, the original function, which you can see and which we don't know what it looks like. But we want to know when f is increasing. So let me give us the reminder here in pink. Down here, I'll remind us that, or in purple, that f is increasing is the same thing as f prime being positive. Right? A function f increases when its derivative is positive. Part A, when is f increasing? Go back to your fact. F is increasing when its derivative is positive. We have the graph of the derivative. So if I have a graph, when is the graph positive? The graph is positive when it is above the x-axis. So look, you see this? Let me switch colors here. What's up with these colors? It's not letting me switch colors. Whatever. So look, right here, you see this purple? This purple part of the graph is above the x-axis. Also here. So these two parts in purple, the graph is above the x-axis. That is when f prime is positive. And f prime positive is the same as regular f increasing. And so for part A, when is f increasing? During these two purple parts. So that would be from -4 to 1, and then from 13 to infinity, right? During those purple parts, those are the x coordinates, where the purple is above the x-axis. Part B, when is f decreasing? F is decreasing when its derivative is negative. You have the picture of the derivative. It is negative when it is below the x-axis, like here. See that? They're in this missing part there. I'll just leave it in blue, actually. This part here, it is below the x-axis. Also here, the left chunk of the graph, which takes you back to negative infinity. These two blue parts, that's f prime negative, which is when f would be decreasing. So I'm going to say from negative infinity to -4. And then I'm also going to say union from 1 to 13. That's what I'm going to say for decreasing. Now, part C, the last part. It wants to know when the second derivative is positive. When is the second derivative positive? Well, how about I do this? Let me see if I can really switch colors. I don't know why my computer is acting up. Can I go to yellow? I think I have to restart my computer, but whatever. Let me see if I can just let me do this. Watch. Let me type this in. Let me type it in down here, and let me say this. Let me say f prime increasing, and then I'll just put equals f double prime positive. So watch, what I've done is this. I took this fact over here, the one here in the bottom right, bottom left. You see this fact down there? Instead of f and f prime, why don't I call this f prime and f double prime? The relationship holds true. Whatever this is, this has to be its derivative, and then the relationship between increase and positive holds true. So now, part C. F double prime is positive. It's right here, look. F double prime positive is the same as f prime increasing. We have the graph of f prime over here. So in this graph, when was this graph increasing? It was increasing from there to there, and then again from here to here. So Part C, f double prime positive, that's when f prime increases. And it increases from negative infinity to negative 2, and then from 5 all the way forever to infinity. So you can expect to see these kinds of things on those solo quiz, along with one more thing. So let's reset all of this stuff. Let's leave this empty. And let's say you have this. State the increase, decrease intervals. Let's say for part A, you have f of x equals, let's say x plus 5. Look, you don't need calculus for this. What does the graph of x plus 5 look like? X plus 5 looks like this. It is a line with a positive slope. This line with the positive slope is always going up. It is never going down. It is always increasing. You don't need derivatives. You don't need critical numbers. You don't need anything other than basic algebra. Here, this line goes up forever. So it is increasing from negative infinity to positive infinity, otherwise known as all real numbers. And it is decreasing never. What about part B? What about for something like this? Let's say for part B, you have f of x equals, let's say like a negative x squared plus 7. You can use Desmos on your solo quiz, on your team quiz, on everything. Bro, I would graph this on Desmos because the graph looks like this. That's what it looks like. And the coordinates there would be 0, 7. So when is this graph increasing? Well, it's increasing from negative infinity to 0, right? That's when it's going up. And then it decreases from 0 onward to forever, from 0 to positive infinity, because it goes to the right and it goes down. No calculus necessary. You would need calculus, let's say, for something like example C, something like this here. And this will probably be our last example. Let's say I have something like e to the x plus 4 minus 5x. I mean, you could graph this on Desmos, and as a matter of fact, I'm going to do that. E to the x plus 4 minus 5x. E to the x plus 4 minus 5x. Watch. E to the x plus 4 minus 5x. So I'm looking at Desmos. I'm not sure if the computer is sharing it, but in case you can't see my Desmos screen, let me go back to my Sketchpad. The graph basically looks like this. Watch. It looks kind of like that. It goes down and then it goes up. So all you got to do is find this guy here, and that's the critical number. The x coordinate there, that's your critical number, which you can find by finding the derivative and setting the derivative equal to 0. This derivative looks like this. E to the x plus 4 times 1 minus 5. The times 1 is because you multiply by the derivative of the exponent, which is just 1. If you set this equal to 0 and solve, you're going to get 5 equals e to the x plus 4. Switch left with right. Rewrite this in natural log form, and then solve for x. X equals natural log of 5 minus 4. I'll put it right there. That is our critical number. While you're copying that down, let me turn that into a decimal for us. So this is about negative 2.39. And you need that so you can decide, if the graph is decreasing or if the graph is increasing. So about negative 2.39. So what you would do is what we did in class, where you make like a number line, you pick test values. But now that I think about it, because it's open Desmos, really, you don't need Desmos to decide the increase, decrease. Your eyes can see the picture. What you do need, like your own brain for, is to find the critical number. This guy here. Find the critical number, which Desmos cannot help you with, especially for like weird decimals like this. You got to know how to find the critical number. You can use Desmos to decide where it's going up and down, but you got to find the critical number, which we just did. So final answer, make sure you have this critical number written down because I'm going to erase it. ln 5 minus 4. Our critical number was this guy here. So now for our final answer, we can say that the picture is increasing from negative infinity to ln 5 minus 4. And the graph was going down. Haha, JK. This guy was actually the decrease. And this guy was actually the increase. Yeah, watch. The graph was going down. Look, the graph goes down and then it goes up. So the graph was going down from negative infinity up until this x value. And then look, it goes up toward the sky after this critical number. So my increase would be ln 5 minus 4, and it increases to the right forever and ever and ever. And that would mean positive infinity. So use Desmos to get pictures to see when things are increasing and decreasing. But you got to find derivatives and go equals 0 and solve to find critical values. So this short video should totally help you for your solo quiz on Monday.